All right, here we are again. This is part 2 of our chapter on lipids for sports nutrition. Here we go, folks. In our first video, we talked about the basic types of lipids, and then we talked about the functions, the dietary recommendations, and the structure. Here we're going to continue. And, from here on out, we're pretty much focusing only on the triglycerides. So you may recall that we talked about 3 different types of lipids. And what we're focusing on is the triglycerides, if I can spell. These are the dietary fats that we think of. Now remember, we also have the phospholipids, and we also have a category that we classified as sterols. But we're going to be focusing on the triglycerides. I figure the more that I say this stuff, hopefully the better, right? If we hear it more, we can get into our brain more, right? All right, so when we talk about fat storage, we're first going to start here. Now, I do like to go back and review a little bit because last chapter we talked about carbohydrates. So it's kind of fun to do a little compare and contrast. Well, it may not be fun to you, but I think it's useful for learning. We talked about carbohydrate storage. We have glucose in the blood, so we have some of that simple sugar circulating in the blood. And then we have stored glucose, which I hope that you're thinking in your head, stored glucose. That's right, glycogen. And glycogen we store in the skeletal muscles. About 2/3 of all of our glycogen is stored in skeletal muscles, and then an additional 1/3 or so is stored in the liver. Talked about that. Well, now let's talk about the triglycerides. So we can store plenty of our triglycerides, just like we can store plenty of glycogen. Here's where we store our dietary fat. Most of our fat is stored where we think of fat, as adipose. Look at this picture of adipose tissue. It kind of looks like fat tissue, doesn't it? Big fat cells, kind of looks like marshmallows or air bubbles. So most of our fat we store in a storage form that we call adipose. And this is the fat under the skin, around the organs. This is what we think of as fat. We also can store a little bit of our dietary fat right in the muscle. And as a matter of fact, I'm doing some research on my own, and for a research study I'm doing, and part of it's comparing sex differences, and we know, this is not going to be on your quiz, but women tend to burn more fat for energy than men. And one reason for that is, of course, estrogen, the sex hormone difference. And estrogen causes women to have more fat in the muscle. But that's an aside. I just got excited because I was just reading an article about it. All right, so we store most of our fat as adipose. We store some of that dietary fat right in the muscle, and we store even smaller, very little bit amounts right in the blood. So those are the 3 places. Make sure you review them. Make sure you review where we have the most of our storage, adipose, and where we have the least of our storage, the blood. Speaking of body fat, this adipose, this is something that we probably know a lot about. In terms of being healthy, not even just an athlete, but being healthy, we shouldn't have an excess of this adipose. We need some fat storage, but we don't need too much. So these are just really generic ranges for a healthy body fat percentage, meaning out of all of your weight, out of all of your mass, for men, for a college-age male, younger male, somewhere between 10 and 20% of that weight should be fat, adipose, whereas women have more, right? So know these percentages. As we get older, women and men actually tend to have a little bit more fat storage. But here you go. We're going to talk more about this in a later chapter on weight management and actually body composition. Okay, how much fat do we actually have? Well, we actually have more fat than carbs. Now, we store a lot of glycogen, so we have a lot of carbs. We store a lot of fat. If I were to compare the both, we have a little bit more fat. And we already know fat gives us more energy than carbs. We already know that. So this is already saying stuff that we already know. Okay. Now, hold your breath here. We're going to talk about some details in fat metabolism. In other words, how do we burn that fat for energy? This is really complicated once we get to the chemistry of it, but let's start simple. In order, our muscles are going to first turn to glucose for energy, right in the blood. Then they're going to turn to that stored glycogen, break it down back into glucose, and then they're going to go to triglycerides. We already know that. Ultimately, for most of our activities, we're burning a combination of both, some fat, some protein, some fat, some carbs. All I'm saying is here at the beginning, we burn more carbs, then we can get to more fat. Here's a nice bar graph that shows us this area here is the fat metabolism. So pretty much we're always burning some kind of combination of carbs and fat, but as we exercise for longer, we burn more fat. You do not need to know these percentages, it's just an example. Now, not so fast, my friend. And my basketball OG fans out there will know who this is. Number one, fat is hard to burn for energy. And number two, we don't burn all of it. So even though we have a lot of fat, even though our muscles like to burn it because it gives us a lot of energy, it's hard to burn. We can still do it, but it's hard. And we can't burn all of it. It's kind of how our body is set up. So here is the part where I'm going to really summarize. If you want to sound smart to someone, you can list all 6 steps of fat metabolism. 1, 2, 3, 4, 5, 6. And each of these steps is like a cascade of kind of complicated chemical reactions. You don't need to know all these. Right now, I'm just pointing out that there are a lot of steps to get to burn that fat. This is why we can't burn it right away, folks, because it just takes longer. It's hard. It takes a lot of steps. All right. So I'm going to pick out some things that are important about fat metabolism. And I know you may not want to get into the chemistry, but we have to, because this is really important. Everything has to be there. We have to have the right ingredients. They have to occur in the right order in order for us to burn fat. It's difficult to burn. All right, so the first thing is we have to break down that triglyceride, just like we have to break down any macronutrient we bring in. In terms of the triglycerides, we ingest fat as the triglyceride. This is the Big Mac fat. That's what we bring into our mouth. We have to break it down in the GI tract, and it gets broken down into fatty acids. Just like proteins get broken down into amino acids, just like complex carbs get broken down into simple carbs. Well, here we go. In order for us to even begin thinking about metabolizing that fat, we've got to break it down. So that's the first step. Just know that we break down the triglyceride into something called a fatty acid, which we already talked about. Eventually, we're going to transport these fatty acids into the blood. We did already talk about this. Lipids are not soluble in water, so they need a transporter. If you're interested in the specifics, most often the transporter in this phase is something called albumin, but you don't need to know that. Just know that when we transport these fatty acids through the bloodstream, it requires a transporter. Eventually, from the blood, we take those fatty acids to the muscle, And then once we're inside the muscle, those fatty acids have to go into the mitochondria. Everyone should remember this. The basic parts of the cell. The mitochondria, it's frequently called the powerhouse of the cell, but the mitochondria is where we produce ATP, we produce energy. So we have to bring the fatty acids into the mitochondria. This is where we're actually going to burn it for energy. By the way, when you see FA, that's just shorthand for fatty acid. This is where we're going to burn that fatty acid for energy. We're going to need a lot of things, so believe me, this is completely complicated. But I'm pointing out one enzyme that we're going to see later. When we get into the mitochondria and we want to metabolize that fatty acid for energy, one of the things that we need is an enzyme called carnitine. Just put that in your memory bank. Carnitine, mitochondria, burning fat for energy. You may already be familiar with, we'll talk about later, some supplements that have carnitine in it. So we can kind of connect the dots here. If someone's taking a supplement with carnitine in it, well, probably the purpose or the goal of that supplement is to increase burning fat. So in fact, it can be used and marketed for weight loss. The thinking being, if we have more of this enzyme, we can burn more fat for energy. The last step is called oxidation. That's when we finally can burn that fatty acid for ATP or energy. I really simplified it, folks. Make sure you're reviewing just what I've circled or put in red. Everything else is extra. Okay. We have to be able to oversee this process. And of course, the brain is the big overseer, but we also rely on hormones. But you can imagine, when we exercise, sometimes we're exercising at a low intensity, you're just jogging. Other times you're exercising at a really high intensity, you're sprinting. So we have to be able to constantly adapt. Sometimes we need really quick energy, so we got to start burning more carbs for really quick energy, because that hill I'm running up, all of a sudden I want to sprint. Other times when our intensity goes down and we're just jogging, we can burn more fat because we don't need as quick of energy. So it's important that our body is regulating what we're burning for energy. So here are a couple little tidbits. We've already established that during pretty much every exercise that we do, every activity that we do, our muscles are going to be utilizing both carbs and fat for energy. We know when we burn more carbs, we know when we burn more fat, and we have to be able to regulate so our brain can tell the body what to do based on the circumstance. Here's what I want to say. Carbohydrate metabolism is much more tightly regulated. We talked about insulin and glucagon, our blood glucose regulators. And they do a really darn good job when you have a healthy individual. So carbohydrate is tightly regulated by these hormones. In comparison, fat metabolism is not as tightly regulated. I mean, there's some regulation, but it's not as good and it's not as clear cut. So instead, our body is able to alter the amount of fat metabolism as needed based on how much fat is available and how much we're burning carbs for energy. So it's not just as clear cut. So what I'm just saying overall is carbohydrates they're more tightly regulated, they're more easily accessible, they're more quickly digested, they're more quickly absorbed, they're more quickly metabolized, give us quicker energy. So carbohydrates, you could make a big argument, are our number one fuel. We're always going to be burning some of them. They're quick, they're easy. For fats, I kind of like this bottom part. So if you're getting anything out of this last slide and this one, these last two slides, the body burns fats kind of based off of the needs not met by carbs. So in terms of regulation, that's kind of how it ends up getting done. But all in all, the process works out pretty well. So with a good diet, proper training techniques, your body should have no problems getting enough carbs and fat to the muscles. All right, let's talk about some more practical applications. Here we go. So we're going to talk about, just like we did with carbs, we're going to be specific about our fat needs, dietary fats, before, during, after. Okay. I already said this. Carbs and fats, we're always burning together. So when we're talking about our fat use, right? Remember, at the same time, our muscles are also utilizing carbs. All right, timing. When we are at rest, if you're just sitting there studying and listening to me, hopefully not falling asleep, at rest, we only burn very tiny amounts of fats. When we begin to exercise, we begin the process of fat metabolism. But remember, fat metabolism takes so long at the very beginning of exercise, we haven't really gone through all those 6 steps yet to actually get the energy. So we begin the process of fat metabolism at the onset of exercise, but we don't really yet get the yield. We don't really have the energy from it yet, but we started the process. Now, as exercise duration goes up, the longer you have an exercise that's maintained, the longer you exercise, you're going to burn more fat. Once we get to close to an hour of continuous exercise, that's when we're going to start to really get the more significant amounts of energy from fat. We get some energy from fat earlier, but it's really at that about an hour mark of continuous exercise when your muscles are really going to start to burn more significant amounts of fats for energy. It's not just duration that indicates how much fat we're going to burn during exercise. It's intensity. So we tend to burn more fat at a we tend to burn more fat when we exercise for longer. We tend to burn more fat at a lower intensity. Because at a high intensity, carbs are our primary fuel. At a high intensity, these muscles need quick energy. So if we really need a quick spurt of energy, it's got to be quick. We're going to be reliant more on carbs. Fat, we burn more at a lower intensity and when the duration is longer. All right, let's go back to our sample athletes. Here we go. Now remember, these are just generalizations, but I'm trying to give some sort of application. Our power lifter is going to be reliant more on carbs. Why? Because it's a very high intensity activity and a low duration. So these are the exact conditions where we're going to burn most carbs. Once we get down to our endurance athlete, this is going to be much more fat. This person's going to burn the most fat because we have a lower duration but a really low intensity. Sometimes I got to really check myself. Lower intensity exercise, but a longer duration. And then our team athlete, like a soccer player, is going to burn both. When Mia Hamm is sprinting down the field to try and score a goal, well, she's using more carbs. When someone else has the ball, she might be jogging, her intensity has gone down, she's burning more fat. So both. This is extra information. You don't need to know this. Studies have shown that we actually burn the most fat at a pretty moderate intensity. VO2 max is our maximum oxygen capacity. It's kind of a thing we use to give a sense of aerobic fitness. But don't worry about that. There are other things that can influence our ability to burn fat. And for the record, overall, we almost always like to burn more fat because fat gives us twice the energy yield. So we like to burn fat in most cases. So here are some other things that can influence how well we can burn fat. And I really tried to be very clear about what I'd like you to know. Someone who is more trained, and I'm talking about endurance training, not the same as weightlifting. Someone who has endurance trained, they're going to be able to burn more fat. Someone who does more endurance training can burn more fat. Our overall diet. If someone increases their overall fat intake, they can burn more fat. But of course, this has a limit. This doesn't mean that we should be eating Big Macs every day. But having a sufficient amount of fat in the diet means that we can really burn the most fat. And how much carbohydrate we bring in can also influence our ability to burn fat for energy. If someone was to bring in too much carbohydrate, and I mean a lot. But someone who brings in a lot of carbohydrates, it can actually reduce our ability to burn fat for a lot of reasons. But we can just be very common sense about it. If we have more carbs, your body's just going to use more carbs because it's available. Whereas if we have our percentages from our diet in the right ranges, there's sufficient carbs, but also not too much so that our body will get to that fat quicker. Okay. Decreases in how much we burn fat isn't always bad. So what I want to say is, I just said burning fat is good. We like to burn fat. But ultimately, we want to burn both carbs and fat. Carbohydrates remain our primary source. And then once we are able to, we want to tap into the fat. But you want to be able to metabolize both. All right. Now, is there an instance when an athlete would need to bring in fat during exercise? We know for carbohydrates, if someone exercises continuously for over about an hour, they would probably want to bring in some sort of carbohydrate while they're exercising. Because after about an hour of continuous exercise, you've gone through your blood glucose stores and you've begun to get into your muscle glycogen stores and your liver glycogen stores. So you begin to go through those stores and the storage shelves are empty, so we need to bring in more. But what about fat? Well, how might, quote unquote, bringing in fat during exercise help us? I suppose if we bring in more fat during exercise, if we bring in more, maybe we'll have more to burn. But actually, there's really no benefit to bringing in fat during exercise for most athletes. In fact, bringing in fat can have a negative effect. Because during exercise, your body prefers nutrients it can break down quickly, carbs. If someone were to ingest the long-chain fatty acids, because they're the longest, they take the longest to break down, absorb, and metabolize. So this could really inhibit movement of things through the GI tract. Not good. However, there's some evidence to support that maybe a medium-chain fatty acids, not alone with carbs, could be helpful for some athletes. You don't need to know this ratio. It's there if you need it. All I'm pointing out is it is those medium chain fatty acids that if there's an instance, in some cases where an athlete might benefit, it would be better to be the medium chain fatty acids, and it will be best to do it with carbohydrates. This would only be the case in someone exercising for a long period of time. And I would even extend that out, maybe 4 to 6 hours plus. So we're only talking about our super endurance. So really, half Ironman, ultra marathons, that's all Tour de France, that's all that we're talking about. Anything underneath 3 hours, carbs. Carbs is all you need. And in this instance, the medium chain fatty acids are best. You can read some other things that are good for overall diet. Limit saturated fat, include omega-3 fatty acids, blah, 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 blah. But don't worry about that right now. Remember, we'll only be talking about fats during activity for our super endurance, 4 to 6 hours plus. Here are some examples. A Cliff Bar, peanut butter, the Ironman course, I happen to know personally. They had cookies in the run aid stations, so that's got some good fat in it. These up above are examples of long-chain fatty acids, so it's not the end of the world. Long-chain fatty acids are just more commonplace. Medium-chain fatty acids might be best in a laboratory study, but out in the real world, there's not a lot of foods that can be taken in easily that have the medium-chain fatty acids. So some long-chain in this instance would be okay. I've given you a label here. I'm not going to ask you this, but what I did is I pointed out some of the ingredients in this Cliff Bar that have some long-chain fatty acids. Now, when I do the Ironman, which I've done 4, now I'm done. Seriously, I'm done. 4, that's enough. My snack of choice when I'm on the bike ride for 6 hours is Ritz peanut butter crackers. And a lot of this is just trial and error. So we'll talk about this later. There's not one right answer for everybody. Some people like the Cliff Bar. Some people have like a peanut butter and jelly sandwich. That's a little too heavy for me while I'm riding. But I like these because I get some of the carbohydrates from the crackers, some of the fat from the peanut butter, and some of the salt on the crackers. So I prefer this. Just giving you an example. All right. What about fat in an athlete's day-to-day diet? There are influences. I know people tend to focus on carbs, but we got to look at fat too. The goal would be to have enough fat in our everyday diet so that when we begin exercising, we can start to increase our fat burning. And it actually is a good thing. And even though we're always going to be burning some carbs and some fat, especially for an endurance athlete, you want to burn more fat and decrease your reliance on glycogen. We're not saying that you're not going to burn any glycogen, but the sooner you can burn fat, the better. So you're just trying to increase a little bit that fat burning and slightly decrease the carbohydrate. Some people have tried, well, if I eat more fat 3 to 5 days leading up to an event, maybe I could burn more fat. No. So this doesn't work like the carbohydrate loading. Not so much. So this does not have good influences. And a long-term high-fat diet. You know, one of the trends right now is this keto diet, a ketogenic diet. This is a really big trend. What if I limit my carbs every day in my diet and I eat more fat? Well, the whole goal of this, if I bring in more fat, if I have more fat coming in, maybe I can oxidize more fat for energy. And you know what? When they put a runner on a treadmill in a laboratory, when they eat more fat in their day-to-day diet, they do burn more fat. But it doesn't increase their performance. So even though they may be chemically burning more fat, it doesn't carry over to a better performance. So it seems to be that having the appropriate amount of carbs and fat, as we've already talked about, is what is best. Carbohydrates we need the most of, somewhere between 45 and 65% of our entire diet. Fat should be somewhere between 20 and 35% of your overall diet. And I wouldn't recommend changing that a lot right before or after activity. You want to keep your body practiced and used to the diet. Okay. I don't believe this link is available anymore, so I apologize. Okay, so let's talk about our sample athletes. We already know our weightlifter, our power lifter is going to rely most on carbs. Our endurance athlete is going to do a carb and fat mixture, but is going to burn more fat. Our team sport athlete, somewhere in the middle, mixture. So if I was to play around with those percentages, remember they come in ranges. You know, carbohydrates should make up somewhere between 45 and 65% of our diet. Fat, somewhere between 20 and 35% of our diet. Protein, somewhere between 15 and 30%. So even within these ranges, we can manipulate it. Maybe our power lifter has the least amount of carbs, least amount of carbs, not a whole lot of fat, but a lot of protein. Whereas our soccer player, they're going to need more carbs. They're running around more. They're going to need a little bit more fat because they're exercising for longer in duration. And of course, our endurance athlete is going to need the most carbs and the most fat. These are not exact numbers. I'm just giving you examples of how you could play around with them to best fit the needs of a particular type of athlete. Okay, I'm going to end this chapter talking about some of the supplements that involve fat or fat metabolism. You do not have to know this yet. I'm just kind of wetting your whistle, shall we say. Here are some of these supplements that we're going to talk about later this semester that influence our ability to burn fat. There are medium chain fatty acids. These are a couple years old, these pictures, so there's probably new, fancier labels out now. But there are going to be some supplements with a medium chain fatty acid. And we know if there was going to be a benefit to bringing in more fat to athletes, it probably would be from the medium chain ones. Here there are claims, but unfortunately research has not yet shown that they really improve performance or lead to weight loss. Caffeine can have a role in helping us mobilize, get more fatty acids ready to be burned. I mentioned carnitine, that's an enzyme. Carnitine is an enzyme that helps us with fat burning in the mitochondria. And then there's something called pyruvate. There's also some evidence says that it can increase fat oxidation. You don't need to know these now. I'm just putting them out there because we will talk about them later. All right, folks, good job. Study hard. If you have any questions, let me know.